Good morning. Today we're going to continue looking at linear equations or equations that have one variable in them. We're going to keep focusing on how to solve these equations and how to determine the number of solutions to equations. As we've started to see the last couple days, not every linear equation is going to have exactly one solution. Some of the equations we started seeing yesterday and on Monday, they might have had no solutions. They might have had infinite solutions, and our goal today is to better understand which type of equations are going to end up having no solutions, which type of equations will have infinite solutions, and which type of equations are the ones that we're more used to that have one solution. As you take a look at the guided problems today, we're going to read through part one. You're going to be pausing the video, trying to figure some of this out on your own. Part one asks you, or it says, attempt to solve each equation below by using inverse operations. Those are the reverse things. I'd take an addition to get rid of subtraction. And then we're going to gather and combine like terms. Gather and combine like terms means we need to get all of the like terms, the x's on one side of the equation, and all of the regular numbers, what we refer to as the constants, on the opposite side of the equation. That's what it means to gather and then combine the like terms. You're going to have to put an image of your work in for each of these equations. So go ahead, pause this video. Try to solve each of these equations step by step using what we're calling now inverse operations to gather and combine like terms. I'm going to switch my camera over to a whiteboard. And again, you should have paused this video. Please make sure you're taking the time to work out each of the red, green, and purple equations. Welcome back. Okay, so right now on my whiteboard, what you can see here is the red equation. 3x minus 5 is in the left expression, and two terms, 5x and positive 5, are in the right expression. They're equal to each other. They make the same value. When we see that we have two variable terms, I'm going to put blue boxes around those variable terms. And when we see that we have two constant terms, we know the equation's a little more complicated. These are the equations that might have one solution. They might have infinite solutions. They might have no solutions. So let's take a look and see what happens when we start trying to gather these like terms. I'm going to put that whiteboard into full screen. So if the 3x and the 5x like terms are not gathered to the same side yet, I'm going to need to use an inverse operation to cancel out either the 3x over here and send it over there, or I could also try to move the 5x from the right side, send it over to the left side where the 3x is. I'm going to choose to move the positive 3x. I'll explain why I picked that one in a second. The way I'm going to eliminate positive 3x is with a negative 3x. That's that inverse operation we talk about. Anything I do to one side of my equation, I'm required to do to the other side. Otherwise, I would have broken the equation. So 5x minus 3x over here, that gives us 2x. Negative 5 on the left side is going to come down. The equal sign comes down. Positive 5, that constant, we haven't done anything with that yet, so it comes down. You can see here the reason I chose to subtract 3x is the alternative was to subtract 5x from both sides. I could have done 3x minus 5x over here and gotten rid of the x's from the right side, gathered all the x's on the left. But to me, it's a little easier to do 5 minus 3 than it would have been to do 3 minus 5. So that's why I chose to move the 3x from the left to the right side. At this point now, all the variable terms are gathered on the right expression, the constant on the left and on the right. So we can't combine them yet, and it makes more sense to move the positive 5 over here since the variables have already set up on the right side of the equation. Negative 5 minus 5 more gives us negative 10, and that's still equal to 2x. At that point, we'd divide both sides of the equation by 2. Division would be the inverse operation of multiplying by 2. But a lot of you might have known 5 times 2 would give us 10, so x is really going to just be negative 5 here. And we can see that from the inverse operation here, negative 10 divided by 2. So as we zoom back out, and we were asked to put in an image of our whiteboard, we're going to now do the same thing for the green equation and the purple equation. But at this point, I'm going to take a look at part 2 and part 3, and I want you to think about them with me. Part 3 says identify the number of solutions to each equation above and explain how you know the answer based on your work from part 1. So at this point, I know this first equation, the red equation that we looked at with an x on both sides, had exactly one solution, because when I gathered the like terms, the x's all ended up on one side, the constants on the other side, and we got just one answer. In this case, the one answer we got was -5, but there's only one solution, one value in the world that would work in this first red equation. Our goal on the green equation and purple equation, we're going to see something a little different. I'm going to switch whiteboards now. You're going to be pausing the video if you haven't already solved the green equation and purple equation. And again, you're going to notice variable terms on both sides of the equation for the green equation. Same thing for the purple equation here. So go ahead, pause this video, try to gather those like terms. And then we're going to really focus on the question, what happens when we try to solve equations with the same variable term on both sides? We see the green equation has x's on both sides, but they're both a 4x. For the purple equation, there's a 5x on both sides of the equation. So solve these out, see what happens. Welcome back. For the first one here, what we should have seen, x is on both sides of the equation. I'll quickly put a blue box around those. Maybe I want to move this 4x over there, so I subtract 4x from the right side. I have to subtract 4x from the left side as well. Because the positive 4x is identical on both sides, when I use an inverse operation to attempt to gather them, all that happens is the x's on both sides eliminate. I'm left with 2 equals 2. We're going to talk about this more in a second, but that's all the equation was left with. The x's disappeared as I tried to gather them. For the other equation, I see 5x as a variable term on the left side. That's a positive 5x. I see a positive 5x on the right side. I'm going to use subtract 5x on both sides to try and gather this left 5x, get rid of it over there, and send it over to the right side so I can combine the like terms. But because it's a positive 5x and a positive 5x, identical variable terms or equivalent variable terms on both sides, they eliminate on both sides when I try to gather them. This time I'm left with -2 as the constant in the left expression, +4 as the constant term in the right expression. What does all of this mean? First off, what happens when we try to solve these equations when the variable terms are the same on both sides of the equation? We see that the variable terms get eliminated on both sides. All that is left over is the constant numbers. So how many solutions do these equations have? Here, we're left with a true statement. 2 is equal to +2. The equation's telling us if you take 4x and add 2, and on the other side of the equation you take 4 times x, whatever it is, and add 2, they're always going to be equal in value to each other. You're just taking the same term and adding the same number to that term. So I could pick any value for x. No matter what I pick for x, we're just going to be adding 2 to the same number. So every number for x in the world works. This is really saying x has infinite solutions. So when your variable terms disappear, what we're recognizing really is this is equivalent expressions up here. 4x, let's full screen this a bit, 4x plus 2 and 2 plus 4x are the same expression. It doesn't matter what I pick for x, every number will work in this equation because it's just the same thing on both sides of the equation. The final one, the purple equation, shows us an example, the same variable terms on both sides, so again, the variable terms eliminate, but this time we're left with something that makes no sense, a false statement. The equation here is trying to tell us that no matter what you pick for x, on this side, you're going to have to subtract 2 from the term 5x. On this side, you're going to add 4 to that same term 5x, so they're never going to be equal to each other. It doesn't matter what I pick for x. There is no solution in the world that could potentially make -2 equal to +4. Here, no matter what I picked for x, +2 will always equal +2. This equation will always boil down to a true statement no matter what you pick. That's why it has infinite solutions. This equation will never boil down to a true statement, which is why it has no solutions. I would recommend that all of you skip the challenge problem and keep moving. I actually lack time to show it to you on the video lesson. If you work it out and have questions, please feel free to grab us and let us know. Good luck on the problems today. If you're working hard, we'll be finishing with Kahoot for our exit ticket instead of Illuminate for the exit ticket today.